to see the answers to your homework from last night. And last night's homework I'll highlight here so you can see it. That's what we're actually doing. We're looking at how those problems were done, if they were done properly. And so that is just the first part of the video. In the second part of the video, I'm going to be explaining the homework for tonight. So here are the answers to the first two problems, showing the results that you should get when you actually run the problem. And so what we were looking for was what was the stuff on the right side. And everything is done by crisscrossing charges. After you, like with iron and lead, have to calculate what the charge is on the cation before you bring the cations across to the other side. And we also had one that had to be figured here. This guy, this guy, this guy, this guy, this guy, and this guy, and this guy. Anyway, all of those dudes can be found in the memorized ions. And so the only one that you really had to calculate to find out what his charge was the iron, because he's in with the bad boys and the transition elements. Okay? That's that part. And in just a second, we'll show you the answers to the last two problems. One thing that I tried to show students in this particular slide is simply what to do on the right side of the equation when you have a polyatomic ion. The polyatomic ion, dichromate, includes its subscripts. So this subscript of 7 is not going to be used to balance the molecule. For instance, if you put him with magnesium, or better yet, let's pick one that has a different charge. Let's put him with potassium. Now, let's do even more. Let's do aluminum. All right, aluminum is a 3+, and we put chromate with him. Dichromate, sorry, Cr2O7. When we go to do the subscripts to balance that molecule, it's going to be not 2 times, 2 minus, there we go. All right, so we're going to have 2 aluminums, and to do the 3 chromates, I have to put the parenthesis. The 7 comes, but not the subscript of whatever he was with on the other side. Okay? He might have been in a different ratio on the other side. But the 7 that's right here, that guy has to be shown when you bring him across to the other side. Okay? You take that one with you. But if I were taking this to the other side, if this was on the left side of the equation, I would take this guy and trash him, but I had to keep this. Okay? Just a real quick little thing there. So what we're looking at right now that's new for today is chemical equations are the old dudes that we've been using for everything. What we've never done is complete ionic equations and net ionic equations. And what makes them different is that they require that you have a metal and a non-metal making ionic compounds. That's why they get the name ionic. But the ionic equations are different than just a chemical equation, is what we've done with ionic equations before. Okay? We've used chemical, but we've never done complete or net ionic. So here we go. Let's look and see what a chemical equation is. This is number 33 of your homework tonight. And I'm going to show you this. I'm going to stop the video, and you can stop the video too, and you can copy this down as your first homework problem. Okay? If you look up here in the problem, okay, we're on page 295, you'll see that they tell you the names of the chemicals that you're going to mix. Rather than doing 1 with 5 like we've done in the past, or 3 with 8, or 6 with 10, they're giving you the name of the compound. And so this is a potassium ion and an iodide ion together. and so we write it Ki. And we make sure that their charges are equal but opposite, or they have to have subscripts. And in this case, they don't have subscripts. The next one was silver nitrate, and that silver nitrate is composed of a positive and negative ion, both of which we know. Silver I've told you about before, so if you have not written this down, it might be a good idea to put it on your memorized ions, because this guy you can depend on even though he is a transition element. Okay, and then we do the same old thing on the right side. We swap the negative ions with the cations. So the cations are passing over their anions to each other, and it's the same old deal on the other side. Now the thing that makes this assignment different from what you did last night is that instead of writing the balanced equation, that's just the beginning. Okay, that's why you're going to need to have a paper folded in half from top to bottom so that you have a half sheet for your first problem, a half sheet for your second problem. That takes care of the front of the paper. And the half sheet for the second side, that takes care of the second side of the paper. Just like we did last night. The difference is you're going to have the complete ionic, and I'm going to stop the video now so my class can copy. You should do the same so that you can copy this if you're doing this to get your homework. One of my students in 6th period summed it up beautifully. What you're doing in the complete ionic equation is you're just separating every single molecule into its ions. Huh? What? I will tell you why the AGI does not separate in just a moment. That was the first question that came up. It was a good one, too. Another question that came up while writing the complete ionic equations was, do you have to do the AQ? Yes. And the charges are essential or the whole thing is wrong. Another question that came up was, AGI, why isn't that separated? And that is because it is a solid. Once this reaction takes place, and by the way, it won't take place unless this happens, the silver and the iodine must combine in such a way that they will not dissolve in water. That's what we call a solid. And that's what we did in class last week when I did the demonstration of silver with another halogen. In that case, it was chloride. Okay? We had silver chloride as our precipitate, or solid. Okay? What you're doing on the last problem type, which is the net ionic equation, is you're going to take the silver iodide from the right side of this equation. He's the solid. He's the reason this reaction goes. And so once he's combined, he will not separate. These guys can be put together by taking away the water. You dry out the solution and you'll get potassium iodide and silver nitrate. That's what you're going to get. So, and the silver nitrate would have to be alone and the potassium iodide would have to be alone. Then when you pour them together, this will happen. And all these other guys except silver and iodide are what we call spectator ions. And so if you start with just silver iodide on the right side and rip him apart to get your left side, you will have what's called a net ionic equation. That makes sense? Yeah? Oops, I didn't want to do that. Oh my goodness, here we go. Let's get that little recorder thing up so I can stop it. Silver iodide is here because it said in the question, forming the precipitate silver iodide. That tells you that that's where the S goes. And in the complete ionic equation and the net ionic equation, both, it is not separated, because this is showing the end of the process of forming this stuff. Over here, we just want to see the guys that came together to make this stuff. How did that sound? Did that make sense? Yes?
How do we know which one?
The spectator ions are everybody except the two ions that make up your solid. Why do we have them there? Nitrate has to be there. Whoa, I had nitrate. Silver and iodide. Oh my goodness, we got to change that. Okay. I'm glad I got this question in class. This is 6th period, and nobody saw that all day long. Thank you, 6th period. And so these are the guys that make up the solid. All right? So we got silver and iodine. Everybody else was there just to get silver and iodine into the water. That's it. And that is the purpose of a net ionic equation, to see what's really happening. Where is the action taking place? Okay? Now, on the second problem, all that I'm saying here, the net of this entire screen is right up here. In the question, it says, no precipitate, no gas. Because of that, there is no net ionic equation, because there's no reaction. Nothing happened. So the chemical equation can be written. We write it just like we wrote this one. Okay? Except there's no solid. Everything is aqueous. Both sides. Yeah? The ionic equation, everything is aqueous. Both sides. And there is no net equation. And this is the only problem that doesn't have the net ionic. All of the others have chemical, complete, and net, because they form precipitates. See? Precipitate, precipitate. And that does it for the directions.